Welcome to the explainer. So you probably use the words speed and velocity like they're the same thing, right? We all do. But in the world of physics, they are totally different. And getting that difference is honestly the key to understanding how basically everything moves.
All right, let's kick things off with a real head-scratcher, one that kind of feels like it breaks the laws of common sense. Here it is. Can you be moving at a totally constant speed, but still be accelerating? I know, it sounds weird, but stick with me because by the end of this, you'll not only know the answer, but you'll get why it works. And it all comes down to that big difference between speed and velocity.
Okay, so to crack this puzzle, we've got to take one step back and look at a really core idea in physics. And that's the difference between something called a scalar and a vector. Now, don't let the names throw you off. It sounds way more complicated than it is, but trust me, this simple idea is the key that unlocks everything else.
So here's the deal. A scalar, it's really just a number. That's it. Think about it. 10 kilometers, 5 kilograms, 60 miles per hour. See? Just a magnitude, a size. But a vector, well, a vector is that same number, that same magnitude, but it also has a direction tacked on. So it's not just 10 kilometers, it's 10 kilometers east. It's not just 60 miles per hour, it's 60 miles per hour north. And that extra little piece of info, the direction, it changes everything. It is absolutely crucial.
And a perfect way to see this in action is to look at distance versus displacement. So imagine you're walking around a park, right? You're kind of meandering on a curvy path. The total ground you cover, every single step you take, that's your distance. That's the scalar. But your displacement, that's the vector. It's just the straight line from where you started to where you ended up. It doesn't care about the winding path you took, just the as the crow flies change in your position. It's the whole journey versus just where you wound up.
Okay, now that we have that foundation, we can get to the main event, speed versus velocity. And you've probably already guessed it, right? One of them's a scalar and the other's a vector. It seems like such a tiny difference, but believe me, it's the source of all the mix-ups, and it's what leads to some really weird-sounding results.
Yep, you got it. Speed is our scalar. It's that number on your car's speedometer just telling you how fast you're going, period. But velocity is the vector. It takes that speed and adds a direction. So saying you're going 60 miles per hour, that's a speed. But saying you're going 60 miles per hour north, now you're talking about velocity.
And to really see why this matters so much, let's walk through a classic physics problem. This example just makes the difference between the two concepts totally clear.
So, let's picture this physics teacher, okay? She's just pacing around in a perfect rectangle. She walks at a nice steady pace, the whole trip takes her exactly 24 seconds, and here's the key part. She ends up right back where she started. Okay, let's break down the numbers. The total distance she walked, if you add up all the sides, is 12 meters. Simple enough. But her displacement, remember, that's her final position relative to her starting position. Well, since she ended up in the exact same spot, her displacement is a big fat 0. And this is where it gets interesting. When we calculate her average speed, we take the total distance, 12 meters, and divide it by the time, 24 seconds. We get a real number, 0.5 meters per second. She was definitely moving. But what about her average velocity? Well, for that, we use displacement, which was 0. So 0 divided by 24 seconds is 0. Isn't that wild? Her average velocity for the entire trip was 0, even though she was moving the whole time, all because she ended up back at square one.
So that whole idea that you can be in motion but have 0 average velocity, it kind of messes with your head, right? It's because we're so used to thinking about speed, which can only be positive. The rules for velocity are a little different, and they can feel weird. So let's clear up a really common misconception.
This one's a biggie. People think, wait, velocity can't be negative, can it? You can't have negative speed? And it makes sense why we think that. You look at a speedometer in a car, it only goes up from 0. So negative motion sounds impossible. But we have to remember, velocity is a vector. It's all about direction.
That little plus or minus sign, it's just a label for direction. That's it. For example, let's say we decide that moving to the right is positive. So object A moves from the 2-meter mark to the 6-meter mark, we'd say that's a positive velocity. But if object B goes the other way, from 6 meters back to 2, its speed is exactly the same, but we call its velocity negative just to show it's going in the opposite direction.
So really, that's all a negative velocity is. It just means you're going backwards relative to whatever you decided was forwards. If we say moving east is positive, then a negative velocity just means you're heading west. It's just a handy label.
All right, time to put all the pieces together. We've talked about scalars, vectors, speed, and velocity. Now, let's finally solve that puzzle we started with. So, here we are, back at the beginning. Can you move at a constant speed but still be accelerating? I bet it seems a lot less strange now, doesn't it? Could your speedometer be locked at a steady 30 miles per hour while you are, scientifically speaking, accelerating?
The entire answer is hiding in plain sight, right in the definition of acceleration. See, here's the thing we get wrong all the time. Acceleration isn't just a change in speed. The technical, real definition is a change in velocity. And we now know that velocity has a secret ingredient.
And there it is. The answer is a big, resounding yes, you absolutely can. Because velocity is made of two parts, speed and direction. If you change either one of them, you are accelerating. So yeah, speeding up is acceleration, slowing down is acceleration, and just turning a corner, that's also acceleration.
Just picture a car taking a nice, smooth turn. The driver can keep their foot perfectly steady on the gas so the speedometer doesn't budge from, say, 30 miles per hour. The speed is constant. But is the car's direction constant? No way. It's changing every single second it's in that turn, and a change in direction means a change in velocity. And what is a change in velocity? It's acceleration. Simple as that.
Okay, so what about we flip it around? Let's test our understanding here. Could you have an object with a perfectly constant velocity, but its speed is jumping all over the map? Nope, not a chance. The physics on this is crystal clear. That's impossible. Think about it. If velocity is constant, that means both of its ingredients, the speed and the direction, have to be completely locked in. They can't change at all. So constant velocity means you're moving in a perfectly straight line at a perfectly steady speed. End of story.
So here's the takeaway. The next time you're on a merry-go-round or even just driving your car around a curve on an exit ramp, remember this. You are constantly accelerating. Your whole body feels it, right? Even if your speed never changes. It's just a fantastic example of how knowing this one little difference between speed and velocity completely changes how you see the world. It makes you wonder, what else is moving in ways you never even realized?